In this video, I will explain how to find a demand function given a utility function. So let's jump into an example. This says, suppose that a consumer has the following utility function. U equals x plus y to the 0.5. Find the demand function for good x. Now, before we find the demand function, one important thing that we need to know is that the utility for this consumer will be maximized when the following is true. When the marginal utility of x divided by the price of x is equal to the marginal utility of good y divided by the price of y. So this is the key equation that we're going to use to actually solve this problem. So we're going to start out by finding the marginal utility of x and the marginal utility of y. So the marginal utility of x, that is simply the derivative of the utility function with respect to x. So the derivative of this function with respect to x, we can see that's just 1. And then we need to find the marginal utility of y. And that's going to be the derivative of the utility function with respect to y. So the derivative of this function with respect to y is going to be 0.5 y to the negative 0.5. So now we can plug these two values into this equation for the marginal utility of x and the marginal utility of y. So here's what we get. 1 over the price of x is equal to 0.5 y to the negative 0.5 divided by the price of y. Now, what we're going to do is we're going to solve this equation for y. Okay, so let's start by rewriting this right-hand side right here. So let's move this y to the negative 0.5 to the denominator to make this exponent a positive number. So we'll have 1 over the price of x is equal to 0.5, that's the same as 1/2. So we can rewrite that as 1 over 2. We can put a 2 in the denominator, and we'll have the price of y times y to the positive 0.5. So now we can cross multiply and set those values equal to each other. So we'll get 2 times the price of y times y to the 0.5 is equal to the price of x. Then remember, we're solving for y. So let's divide both sides by 2 times the price of y. So we'll be left with y to the 0.5 is equal to the price of x divided by 2 times the price of y. And the last step to get y all by itself is to square both sides. So we'll find that y is equal to the price of x divided by 2 times the price of y, and all of that is squared. Now, the last step to find the demand function for good x is we're going to plug in this value of y into the budget constraint. So I'm going to clear a little bit of space here. Okay, so here's what we found for the value of y. What we're going to do is take this value and plug it into y for the budget constraint equation. So this is the budget constraint equation. We say that M, the total budget of the consumer, is equal to the price of x times x, which is the quantity consumed of x, plus the price of y times the quantity consumed of y. So let's go ahead and plug this value in for y right here, and we're going to solve for x. So here's what we get. M is equal to the price of x times x plus the price of y times the price of x divided by 2 times the price of y squared. So if we simplify a little bit, we get M is equal to the price of x times x. Then we'll have the price of y times, when we have this expression squared, we have to first square the numerator. So we'll have the price of x squared. And in the denominator, we have to square the 2, which is a 4. And then we have to square the price of y, which is the price of y squared. So we get M is equal to the price of x times x. We'll notice that the price of y cancels out with one of the price of y's in the denominator here. So we'll be left with plus the price of x squared over 4 times the price of y. Now remember, we're solving for x, so we can go ahead and subtract this entire expression here, and we'll have m minus the price of x squared over 4 times the price of y is equal to the price of x times x. And lastly, to get x all by itself, we can divide every term by the price of x. So let's go ahead and write this over here. We'll have m divided by the price of x minus the price of x squared over 4 times the price of y times the price of x, which will be equal to x. So we'll notice that we can cancel out one of these price of x's in the denominator and one in the numerator. So we'll be left with m over the price of x minus the price of x over 4 times the price of y is equal to x. So this is the demand function for good x. I'm going to go ahead and rewrite this with x on the left-hand side. So here's our final demand function for good x. We say that the quantity demanded of good x is equal to M, the total budget of the consumer, divided by the price of x, minus the price of x divided by 4 times the price of y. So it is a messy solution, but that is the answer for the demand function for good x.